Hello, dear listeners. Welcome to Semaphore Uncut, a podcast for developers about building great products. In this episode, host Darko welcomes Tauri co-founder Daniel Thompson-Yvetot. Daniel and Darko talk about memory optimization, security on hybrid apps, and what Tauri brings to the table. We hope you enjoy this episode. Now let's dive in.
Today, I'm excited to welcome Daniel Thompson. Daniel, thank you so much for joining us.
Thanks for having me.
Great. Can you please just go ahead and introduce yourself?
I've been working in open source software since the early aughts. Was involved in community networking. I always kind of had this mixed drive to facilitate communities and do so in a creative way. And the software industry has changed a lot in the past decade or so. I mean, for a while, you had to be some kind of C++ ninja or writing things in some kind of low-level programming language, and it always seemed unattainable. And as time went on, the community started getting these really great tools. One of them was Atom Shell, and then there was Node WebKit. And what a lot of these application frameworks had in common was they helped people make applications really easy. And that was really intriguing for me as I developed myself as an engineer. As time went on, it became really easy to have an idea and make something that worked. And I think for a lot of people, that's always been sort of this interesting idea behind the classical hybrid apps.
For us who haven't really dealt with that stack and with Tauri, can you give us like a technical overview in terms of those dependencies and runtimes? Can you compare those two stacks and then maybe do a technical introduction of Tauri?
Let's start with the similarities, right? Every app needs a harness that boots it up, right? And Tauri has chosen to use Rust in order to do this kind of bootstrapping phase. And Electron has chosen JavaScript. Now they're using Node.js as the application harness, which, as we know, is based on a bunch of amazing C++. And the application harness basically just gives you a window, and that window then gets filled with a web view. So Electron is embedding Chromium. It doesn't matter if you're using Windows, Mac, or any of the flavors of Linux, you're going to get a Chromium. And Tauri uses the system web view. So on Windows, it's WebView 2, which, spoiler alert, is also based on Chromium. On Mac, it's WK WebKit. And on Linux, it's WebKit GTK. The difference kind of starts right there because the application size of an Electron app is never going to be smaller than what it needs from Node.js and what it needs from Chromium. So you have this minimum bundle size of, let's say it's 30, 40 megabytes. I'm not sure exactly where they're at these days. It's something like that. And with Tauri, we are trusting the system that the user is using to ship a modern, up-to-date web view. So we don't ship the web view, we use and leverage the one that's available on the user's system, which removes, let's say, 30 megabytes of size from the app comparison between Tauri and Electron. Now, it's great to have a web view, and it's great to have a low-lying engine, but the difference between shipping a Node runtime and what Tauri does is that since we're using Rust, we're actually compiling the actual code points that the application needs to, bootstrap itself, but then also later on down the line, interact with system APIs and kind of the whole application syntactic sugar, if you will. And that can be very small, depending on how conservative you are with your API usage. That core of a Tauri app can literally be several hundred kilobytes. Now, the next point is that once you have a web view, you have to put something inside of it. And web views are based on browsers. So like we said, Chromium is based on the work being done for Chrome. It's the open source port of it. And those browsers, they need HTML, JavaScript, CSS. I mean, you can get away without using any JavaScript if you don't want to interact with the system APIs. But generally, if you want to interact with the file system, or you want to interface with the cryptographic primitives inside of Rust, you have to use the JavaScript API to communicate across the bridge between the front end and the back end. In Tauri's case, we actually use a message passing. So since the back end or the core of a Tauri app is written in Rust, we have to send a message that can then be interpreted by Rust as kind of a signaling system. Whereas the bridging mechanics of Electron apps are basically empowered to, I mean, if you're clever, you just send messages, but there are ways to directly interface with low-level systems, and you're kind of passing JavaScript handles back and forth. And for a lot of security reasons, that can be quite scary. One of the larger complaints from the Electron community that we have been a part of for a long time is that when you bundle a final application for Electron, you have, like I said, this HTML, CSS, and JavaScript, maybe some WASM, that is the built artifact that you ship with your application. And the way that Electron does this is they convert these code points into what's called an ASAR. And they ship the entire ASAR blob with the binary, and it's absolutely trivial to decompile. I mean, there's just a command on the command line, ASAR, I think it's -R or something, I don't remember. And that can then regurgitate the entire source code. So what this means for projects that are not open source, that are potentially proprietary, is that anyone can copy your app. And while some might think that's not such a big deal, if you've got backend services that you're not shipping, or you're an open source project, the tricky part comes when it's absolutely trivial for someone to copy the entire working schemata of your application and repackage it. And, that's a way for a lot of illicit applications to be built and shipped to users who just look at it, think that it's the way it's supposed to be. And the way that Tauri does it is slightly different. We allow, like Electron, everyone to build with their favorite front-end framework, like whether that's Svelte or Solid.js or Vue or React or Preact or pretty much anything that you can build a website with, we can ship. But when it gets bundled into a Tauri application, there's no easy way to decompile that. Of course, binary reversing is a very complex industry, and it is possible to get insight into how things are glued together, but you can't just copy and paste what goes into a Tauri binary and reconstruct it on the other side. So the final piece of the puzzle is actually the bundling of your application and the distribution of it, as well as the management of updates. When we were starting our journey of building an updater, we noticed that there are here and there some strange vulnerabilities on different platforms that have to do with the way in which signatures are compared. And we decided to just straight out build an updater service into Tauri because it doesn't make sense to have that as a bolt-on feature. It needed to be inside of core because nobody builds just one version of an app. It doesn't happen. Everybody is always shipping the latest version. And I mean, if you look at the scope of vulnerabilities that are constantly disclosed in Chromium, for example, what you have is a hotbed of vulnerabilities to the point where you have to keep your applications updated every time there's a new version, because otherwise you're just shipping applications as a vulnerability. Our approach there was to follow a kind of common infrastructural approach to the final mile of app development, which, as I said, is ultimately shipping these binaries. And the way that we conceived it is that, you can read all about this on our website about the updater at tauri.app. But basically, in a nutshell, you configure the platforms that you want to ship to inside of one singular configuration file. And then depending on the platform that is being used to build that app, whether it's Mac or Windows or Linux, then you will get these features baked in. Now, for Mac OS, it's kind of trivial. As long as you have your development keys from Apple, you can sign the binary inside of your CI. And for the open source community, we built a GitHub action that is maintained, kept up to date, has also been audited, that allows you to publish your application directly to GitHub. so that you can then use that in a stage of your CI to ship it out with Cloudflare or grow your own service. And we also designed that service to interact perfectly with this ecosystem so that when there's an update, the update blobs get put on your update or distribution service, and the latest versions with checksums and public keys, etc., are placed inside of a JSON file that you then make available to your app users and, well, to the system that the app uses. And depending on what your business logic is, you could always force an update. If there's an update available, you freeze the app from working until they update, or it could be optional. And because of the way that that system hooks in deeply to the Rust core, it's possible to, make even more granular decisions. Like if there's an update available, inform the user. Maybe you want to have it only available on a certain subnet. With this collaboration with the community, with developers, and with amazing team of people behind the scenes building the libraries, what we've found is that Rust isn't that hard. It seems like there's this big mythology that, Rust it's got a compiler and it makes things complicated. And a couple people that we've met that just joined Tauri without any idea of what Rust is or means have turned into amazing contributors. And one of them will never go back to JavaScript.
Microservices architecture is all the rage these days. But do you know what it really means and how to implement it to empower your teams to make the best decision for the problem at hand? On the Semaphore blog, you can learn about microservices and how to take advantage of features like test reports, monorepo, and Docker support to build, test, and deploy your microservice application at scale. Head over to semaphoreCI.com/blog for more information. And happy reading!
Can you describe us you did to some extent the developer experience of getting started?
You can develop a Tauri app on any platform. You just have to install Rust. The majority of people will want to be using a JavaScript-based front-end framework. So generally speaking, that's done with Node.js. Once you've installed these two prerequisites, so if you're comfortable with JavaScript or TypeScript, then it's really, really, really easy to hit the ground running. Now, what I always end up recommending is that people who are new to Rust take the Rustlings course. There's an amazing repo on GitHub called Rustlings. The amazing part, I would say the big differentiator between writing your app in C or C++, or Python or Go versus writing the backend in Rust is the compiler. The compiler really, really helps you understand where the mistakes are. It's really, really friendly. I mean, looking at our plugins, for example, is a great way to learn about how to bridge between the front end and the core. Then you can start to experiment, and it will help you become a better engineer just by learning Rust, even if you're not spending all of your time writing it. Learning about it and learning about type safety, for example, is probably going to be the reason why you switch over to TypeScript. It's probably going to help you rationalize the messages that you're passing around. And the point is to come back to the developer experience. Like these thought processes that were never in anyone's mind because, we're just happy to get it to ship is not good enough for us at Tauri. We want you to ship a secure app as small as possible that performs perfectly on every device you ship it to. And that's the confidence we want you to have when you're building your app. You will know that we got your back and that we're always willing to take criticism and advice. And that initial journey of becoming a Tauri engineer or a Tauri developer is a lot less complicated than you think because Rust isn't scary and you can learn as you go. And our community is an amazing resource too.
Message passing as a mechanism to build the software in a good way, which is very reliable. And with CI/CD, the most important attribute is like a stability. We embraced Elixir within our company, and through that, a lot of people in our development team just got that amazing exposure to message passing and how good it is. Can you maybe talk a bit deeper about how that works?
We are sort of required to do message passing, to pass a message from the web view to the Rust core because of the way that web views are constructed. There's a special interface. Generally, I think it's window.external, and that's something that both sides can listen to. Now, the web view in our situation is less privileged than the Rust side, because from Rust, you can literally just address the web view and tell it to eval anything at any time. Rust owns the process. Now, from the web view side, in order to, let's say you want to invoke a command that reads out the contents of a directory, the application developer needs to grant certain permissions to the application for it to read certain folders. And you granted that permission to the application in your configuration. And then the user opens up the application and they have one button that says, show me the contents of the app folder. And they press that button. What happens is the window external interface receives a message sent to it from JavaScript that says, I have a message here. It's an invoke function. The invoke function should be reading from the file system at this folder because I'm allowed to, and I want to get the contents back. So it's a structured message that gets sent across that boundary. And on the other side, in the main loop of the Tauri application, there's something like a listener that says, oh, just got a message. And this message says invoke, list this from the file system, permissions check out. All right, this is what's there. And then it returns a structured message across the boundary. Again, obviously we could have just evaled into a DOM object or some kind of JavaScript prototype. The problem with that is, how do you make sure that JavaScript is aware of it without constantly analyzing that prototype? We felt that the cognitive load would be reduced if it's the same system going both ways.
Yeah, absolutely.
When you're in a JavaScript context, you don't always, you think you know what's being run there, but you're not entirely sure. One of the approaches that we've taken to deal with this complex situation actually uses an iframe. And in this advanced model where you want to isolate the backend from a potentially dangerous user interface, the isolation pattern serves to qualify the source of the API call so that, for example, illicit code can't spawn a shell command that deletes your etc. folder. And the next security feature that is a very, very dangerous vulnerability is the entire object prototype of JavaScript upon which JavaScript is based. And a lot of front-end frameworks actually modify the prototype. And some of them, like Vue, they do freeze the prototype after they've modified it. But during bootstrapping, it's wide open. And there are other frameworks out there like Svelte and Solid.js are two that that don't require any object prototype modification. So what that means is on Bootstrap, we can freeze that prototype. So we're trying to apply these lessons learned through decades of development on websites to actually make something better than the sandbox of the browser.
Thanks for the explanation and the overall introduction. For the people who want to know more about the project, maybe get started, follow you, can you give us some of the resources?
Sure. The first place to stop by is tauri.app, and that is where we host all of our onboarding documentation, our API documentation. We have some recipes in there. We try to walk you through what you need to know on your journey from setting up your system to developing your app, to testing your app, to building your app, to shipping your app. And that's a great place to start. On that website, you'll find links to our Twitter, which is Tauri Apps, and you'll find a link to our Discord, where the majority of the conversation takes place. Nevertheless, we also maintain a GitHub repository at Tauri-apps, and that is where all of our repositories are held. They're dual licensed MIT, Apache 2. And depending on your needs, it's probably best to just stop over at the Tauri repo, look at the README, check out some of the discussions. And if you have any problems, just file an issue. we might say, oh, this has been solved, or it's upcoming, or we might even transfer it to a different repository. We might just say, hey, this is complex. This isn't an issue for GitHub. Why don't you come by and we'll help you triage over at Discord.
Well, Daniel, thank you so much for sharing. Good luck with Tauri. And I'm looking forward to hearing how it develops over the years.
Thank you. Thanks for having me, Darko.
What a great conversation. We hope you enjoyed it and learned something new. Make sure to subscribe to Semaphore Uncut on your podcast player of choice so that you don't miss our new episodes. And